Hello everyone. So in this pre-lecture tutorial, we're going to talk about how it is that chemists connect the mole concept to measuring out amounts of materials in the chemistry lab. And the link between the mole concept and the mass scale is this concept that we call molar mass. Now, essentially, when we're discussing the molar mass, what we're doing is we're talking about the amount of mass that we associate with 1 mole of particles of that particular substance. So, for example, for an element, we're talking about the mass of 1 mole of atoms. Now, if you recall, we've already talked about atomic mass earlier in the year. And so as it turns out, for an element, the atomic mass and the molar mass are the same as one another. So, for example, suppose I wanted to find the molar mass of aluminum. Well, I would look in the periodic table, and as we're aware, this number down here at the bottom of aluminum square is the atomic mass. Now, as a standing rule for the rest of the year, every time that we go in to find an atomic mass or a molar mass, let's just say that we're going to report it out to 4 significant figures. And so that means for this particular number, we would report out 26.98 atomic mass units if we're talking about the atomic mass of aluminum. However, even though for aluminum the atomic mass is 26.98 AMU, if I want to create a conversion factor that interrelates moles and grams, then I need the units to reflect that. So I would report out the molar mass of aluminum as 26.98 grams per mole. However, when I am trying to find the molar mass of a compound, then what I'm going to do then is I'm going to add up or sum all of the atomic masses for all of the atoms, or in the case of ionic compounds, ions, present in the compound. So, for example, suppose that I wanted to find the molar mass of sodium bromide. Right? If I were to look up sodium's molar mass, that's 22.99. So for sodium, that would be 22.99 grams per mole. But to that, I would have to add the molar mass for bromine. And if I look up bromine, its molar mass would be 79.90. So that would be plus 79.90 grams per mole. So if I add that up together, I get 102.89 grams per mole. All right. Now, what if I had something a little bit more complicated? Suppose I had lead 2 sulfate. Okay, well, I'd need the molar mass of lead, the molar mass of sulfur, and the molar mass of oxygen, but I'm going to have to multiply that molar mass of oxygen 4 times because there are 4 oxygens in lead 2 sulfate. So then, if I look it up in the periodic table, the molar mass of lead would be 207.2 grams per mole. For sulfur, it would be 32.07 grams per mole. And for oxygen, I'd have to multiply that molar mass by 4, again consulting the periodic table, then that would be 16.00 grams per mole if I report it out to 4 significant figures. If I add all of this up, then I should get 303.3 grams per mole. All right, let's do one more example. Suppose that I wanted to find the molar mass for calcium hydroxide. So I need the molar mass for calcium, molar mass for oxygen, but I have to multiply that by 2 since there are 2 hydroxide ions in calcium hydroxide, and I'd also need the molar mass for hydrogen. But again, I'd have to multiply that by 2, since there are 2 hydroxide ions in calcium hydroxide. So, looking at the periodic table, calcium's molar mass is about 40.08. As we said earlier, oxygen's is 16.00 grams per mole, and hydrogen's is 1.008 grams per mole. So, I would go and I would take 40.08 grams per mole for calcium, add that to 2 times 16.00 grams per mole for oxygen, and lastly multiply that by 2, or I should say multiply 1.008 grams per mole by 2 to represent hydrogen's contribution to the molar mass of calcium hydroxide. And if I go ahead and add all that up, I get 74.10 grams per mole. So go ahead and complete the follow-up assignment where you have to do more of these molar mass determinations. In the next pre-lecture tutorial, we're going to work on finding out how to use these molar masses as conversion factors. But for now, just worry about finding these molar masses for different compounds in the follow-up assignment, and also in class we'll reinforce this as well. If you have any questions, by all means email. Otherwise, I will see you guys in class next time. All right, have a good night.